Good evening, and welcome back to Saturdata with what is for me the last notebook of season one, the last of the deep dives. Today, I'm really excited to be talking about this one. I've been working on it for way too long, so I need to go ahead and get it out into the world. This this notebook is going to be talking about something that I've been working on for many years through different companies and in different times that I've decided, why am I using pandas, right? I should probably be using something a little bit more designed to be working with the data that I'm working with, the size of the data I'm working with, right? And the first thing I came upon back in 2022, I think it was polars. I took some time and was using polars at work at the time and was learning the API, and I really liked the API for polars. I thought it was very pleasant, a lot easier to understand and work with than pandas. But I still use pandas a lot, and so did people at my work. And even now, still today in 2026, I still use pandas. I still refer back to it sometimes. It's not something that's completely out of my day-to-day. But I would say it's definitely fallen by the wayside, right? It's not the first thing I'm going to look to, as it was for a while when I wanted to go work with data frames in Python. Now I have other things that I default to when I need to use data frames in Python. So this is TCP-H benchmark performance at scale. TCP-H is a very well-known industry standard decision support benchmark, as the notebook says here, but just a well-known benchmark comparison for different things, running the same queries, using different technologies across different, the same data set also. Really things that differ are machines, right? The machine that people are running these things on, and what language, right, you're going to use with. So if we're going to use Python and DuckDB, if we're going to use Go or whatever other language you want to use to hit the TCP-H data, you can use that. Obviously, also the data manipulation packages, Pandas, Polars, Arrow, PyArrow, specifically for the Python ecosystem, DuckDB, all these different things we can test using TCP-H because it's the same queries on the same data, which is very helpful to understand how these things perform. We today are going to be comparing, as you see here in the lineup, pandas with a PyArrow bolt-on, just using PyArrow in the backend, polars, and DuckDB. The test we're going to run across 6 different scale factors for TCP-H query number 6. We're going to be measuring execution time, memory usage, and scaling behavior. First thing we're going to do is go ahead and load in all of our packages. There's hypothetically a query selector drop down here that doesn't work, but you can see here the 2 different queries that you could run if you wanted to. You could change this value here to Q1, and you would have it working. You'd be able to use it. So thing is spinning still. We're gonna go ahead, maybe kill this and start it back. Didn't want to kill it and start it back. And then here, so as we'll see moving forward, Polars actually has, and thanks to Richie for explaining this on LinkedIn. I'll try to tag him here in the show notes. Polars has 2 different ways you can load in data. You can force asynchronous execution, avoiding mmap, or you can utilize mmap, right? By default, this force async value is set to false, which will use the memory map Parquet readers on local storage. This could show high memory usage just as we move forward, right? There's a different way to set polars to not use the memory map Parquet readers, and it'll switch it to an object store byte source that avoids the memory map Parquet readers, which is just polars force async equals 1. This can reduce memory pressure and memory usage, but also causes performance implications in polars. So you could test that out. In this, I'm only presenting one here in this notebook, just to be clear. So you are going to see, higher memory usage on the polar side because of that. You could decrease just an active trade-off, right, with speed and performance, but it's not anything that would make you say, no, we can't use that. Polar's memory mode, so just explaining that more here. Setting the memory mode, we are going to go ahead and kill this. It has decided it did not want to work. Start up a new one. All right, I'm going to run through the first couple. All right, Polar's memory mode. Now we're setting it. Now we're loading in Polars. Now we're giving you an overview of the data set. I'm actually going to go ahead and run all the cells I need to run because that test does take a while. There we go. All right, good. Test is running. So to introduce you to the data set and what we're working with, TCP-H line item, it's the largest table. The line item table is containing 16 columns, prices, quantities, dates, and shipping information. The schema is listed here. I'm not going to go ahead and read that out to you, but then we're going to test across 6 different data sizes. We're going to test all the way down from 20 megabytes, something quick and easy, to all the way up to 2 gigabytes. There are tests or benchmarks online that test larger, but I felt like 2 gigabytes was good enough, right, to get a decent understanding of performance and go through and you can compare all of them as well. We're setting our data path here. We are setting the scale factors that we want to test. If you were to only want to test a couple, I did this earlier, just comment that out, right? And then you could test just these 3 scale factors instead of having to test all 6 of them that we have currently loaded in. The TCP-H data files existing, that's all this is doing, and the benchmarking methodology. So I played around with this for a long time and eventually landed on that each benchmark, even though we're running in this notebook, each benchmark, easier to read it from here, will run in its own isolated sub-process. This will make sure that there's no shared kernel contamination between the tests. I think I was seeing some effects of that earlier, and maybe I wasn't, but I wanted to make sure that this was the main issue for me, right? These other things that, AI added in. But really, I wanted a clean slate each time I did a test, and I still wanted to present the test to you in a notebook format. So this, this using Opus 4.6 was able to build that out, which is very helpful because not something I would have been able to build out as fast as this did without it, right? And I still spent a long time on this. So we're going to use peak RSS and then returning the peak RSS delta, right? Whatever the peak was minus the baseline RSS when we started execution. We're pinging every 50 seconds or 50 milliseconds, during the execution to get the thread. So we could go lower in milliseconds execution, but I don't want it to actually impact the performance also of each sub-process. So I laid it on 50 milliseconds. So it'll capture all memory allocations, Pandas, Python objects, including native library allocations. Polars is in Rust, DuckDB is compiling to C++, and PyArrow, right? Memory map files and buffers, and then Y scale. We can see linear scaling, we can see sublinear and superlinear scaling, right? So when superlinear is like exponential, closer to, right? Whereas linear is, okay, it's getting bigger and it takes longer, it makes sense. Sublinear, i.e. being the size doesn't matter. It's not O of n, it's something like O log of n, right? Super linear would be like O n squared, and linear would be like O of n. As far as time complexity goes, this shows which libraries are ready for production workloads. Yep. Benchmark operations subprocess. So the actual benchmark code is happening somewhere else. As you can see, it's in benchmark worker.py. But we do build a subprocess here, the system executable with the worker script as defined here, the path to the worker script. Then you pass through the library, the query you want to run, the scale factor, and where the data is actually located at, logging out the subprocess, and environment variables, and timeout. Parsing JSON output, and replacing library key with a display label. Just don't worry about that. So we're running benchmarks across all scale factors. 7 because I was doing something earlier. It's 4. And it's not going to be 42 benchmarks. It's going to be 24. It should take, 5 to 10 minutes. Pandas, PyArrow, polars, and DuckDB using duck.sql. As you can see, these are the ones I commented out from earlier. Had out at 7 noted, now I have 4. I was trying out a couple different ways of calling DuckDB. Landed on just the duck.sql as the one that had kind of the best performance from a DuckDB standpoint. So I did test other ways. Don't come at me saying I didn't test everything. But there are some things, like I didn't test the separate polars one. I'll leave that as like a cookie for you to go test the separate polars force async implementation and let me know what you get. Also, let me know if the results I get from this test come out to be anything similar that you're getting. Like I said, there is some variation here because you could be running this on your machine. Our machines could be stronger at different things, but generally, don't expect our results to be changing conclusions or having us change conclusions based on the results. Measuring the memory pressure for both polars and DuckDB mostly at times was kind of tricky. Luckily spent enough time with it to figure it out, and also with some help from the LinkedIn community. So thanks for everyone who chipped in there. I'll try to add some of those people also in the show notes, so that way you can kind of bounce off and go learn and follow some other really interesting people there on LinkedIn. So as you can see, we're running the scale factor of 0.1, scale factor of 0.5, scale factor of 1, 2, 5, and 10 will be the last scale factor we run. Right now, it's actually running the Pandas, classic Pandas, scale factor of 10. This one takes a long time for obvious reasons. Pandas over 2 gigabytes of data is not going to run quickly, which is why I wanted to start that test a little bit earlier before we got down to this. And as we see here, we're now waiting. It should finish up here in a minute or two. And I'm going to go ahead and pause until then. All right, just wrapped up the test. Took maybe 4 more minutes due to the sub process. None of these things actually take that long. The Pandas does take kind of a while on the 10. What's that? Like 3 minutes and 13 seconds. So it does take a lot longer on the 2 gigabytes there of data. This is like 2.1 gigs of data, 60 million rows. It took 3 minutes and 13 seconds to run, and peak memory usage was 12,000 megabytes. We'll do some visualizations here now. So this is how this looks. Log scale, execution time in seconds. Your x-axis is the data set size, right? So we ran 6 times, so we'll have 6 different points here for each of the technologies, methodologies. And on the y-axis, we have execution time in seconds, right? So moving up, you'll see obviously classic Pandas and Pandas with PyArrow here are kind of the ones moving linearly. We'll see the scale factor of 0.1, 20 megabytes. Pandas took 1.43 seconds. The Pandas with PyArrow took 0.9 seconds. Scrolling all the way to the other end of this. Pandas, scale factor of 10, 2 gigs, over 3 minutes. Pandas with PyArrow, scale factor of 10, 50 seconds. So this gap actually I don't think does it enough justice, but we do this more as a comparison's sake. Note again, we have log scaling here in the time. Notice how the lines are, right? So notice there's a lot of lines between the blue and the red here. Those are your lines. And then we'll move all the way down to the green and the yellow, and no surprise, or orange. No surprise that this represents polars and DuckDB. Polars here is on top in the green, and you'll see polars with a scale factor 0.1 took 0.16 seconds. Again, compared to Pandas 1.43 seconds. That's a huge scale up factor, speed up factor. DuckDB size 18.1 megabytes and 0.05 seconds. So also a big difference between polars. It's like 3 times faster on that small data size. But you see, as the data starts to get larger, they start to get closer together. All the way on the other end, 60 million rows. Polars still under a second, under half a second, even at 0.38, and DuckDB at 0.27. And you'll see this is where memory usage starts to increase too if you're looking at the tooltip. So we'll do the same thing here for memory scaling. This is not log, this is just peak memory. And again, that's peak, right? Now I noticed the Pandas and PyArrow is continuing to increase every time with the peak. That's not something that I've spent too much time to try to debug and figure out if that's actually what's going on or if the methodology is in question. But I think it's worth asking and worth diving into. Again, I just wanted to go ahead and get this out for you so we could look at it a little bit deeper. And you see the blue line here is Pandas. It does actually start to go down the peak memory pressure once we hit this, 1 gig of data, 30 million rows. Spend a lot more time, right? So that's the thing. Is it from 64 seconds with 13 gigs of peak memory pressure, 12.5 gigs of peak memory pressure, so it's less, but it's 3 times as long, right, in terms of how long it took to get that work done. So if we go over here to Pandas and PyArrow, and let's look at the peak memory pressure, right? It's at scale factor 5, it is 8.2 gigs, and a scale factor of 10, it is 16 gigs. So we doubled the scale factor and we doubled the peak memory. Yeah, I'm not sure about that, but that is what the test shows. And then as you see here, right, things stay low. We do have peak memory of 488 megabytes for polars at the top end of the data set size in megabytes. Again, data set size is your x-axis, peak memory is your y-axis. So the largest data set size, peak memory is 488 megabytes for polars. But remember earlier how we talked about the polars is based on the way it works in the memory map. It'll use more memory if the memory is available. Right, so if we were to force the async, we could bring this memory down and we'd see a different comparison time-wise. But notice too, I mean, the polars is higher on time and polars is higher on memory. So if I'm telling you that I can bring polars memory down closer to DuckDB, this green line is going to go further up, right? Because it's going to take longer, and as is, DuckDB is already faster. So, and then you'll see here on the 2 gigs of data, peak memory usage in DuckDB. DuckDB is 93.6 megabytes. So we're like a quarter of the data usage or the peak memory as polars, while still being right 0.27 to 0.38, 0.1 seconds faster. But as a proportion, we're more like it's like 33% reduction in time, right? While having like a 4x reduction in memory. So it's pretty solid. So say those are good numbers to have. If you're DuckDB, you're looking good. And then this is just, couldn't quite figure out the axis on this. I played around with this for a while, so I have to go back and look at it. But this is memory pressure. Sorry, this is I think it's memory pressure for SF1. Sorry, time comparison for SF1. So again, just visualizing the specific scale factor of 1, 200 megabytes, 6 million rows. You have Pandas here. Pandas with PyArrow here. We're not on a log scale anymore, so we're just looking at it as is. But again, the axes are all screwed up. In polars and DuckDB. So, the benefit here of Pandas and PyArrow, right? You might say like that's just like I don't know, like a middle child. It's like, what are you doing? But Pandas and PyArrow, the benefit of this is you can it's a really simple code change to tell Pandas, hey, instead of doing what you normally do, I want you to use PyArrow in the back end. So in an enterprise setting, like that's a lot easier a battle for you to have, and the easy win for you to say like, hey guys, I can do this and I can make this run this much faster, this much more Again, the memory pressure thing I'm a little worried about, but we'll have to look into that because PyArrow should be better on the memory thing. But if you have infinite memory, I guess, right? And you can cut this time in. This was a lot less. It was like 3 times less, right? Then that's going to look really good for you. And you're going to buy yourself time to do other things like explore polars and DuckDB. I mean, at this point, it looks like DuckDB is kind of the takeaway here. So, classic pandas, working with small data sets. I mean, there's, we can say when to use each library. Classic pandas use when working with small data sets, but that used to be how we thought about things. I was like, yeah, just go ahead and use pandas like whenever. That was when most of us defaulted to pandas, right? So that's why this guidance is in this notebook. It's because at a time in life, we would always default to pandas, and these new technologies, i.e. DuckDB, i.e. polars, we didn't have time to necessarily learn the APIs. We didn't necessarily have time to learn the other pieces around it. But now, either you use AI or you take the time to learn it, or you already learned it because we're not pandas forward as much as we used to be as an industry, right? So mainly I would say this, like if the team is most comfortable working with pandas and you have really small data sets, take those two things and say, okay, like pandas is our decision. Really, like avoid when we're using pandas in production, right? I don't even know if I would use pandas in production anymore. But this one, pandas plus PyArrow, right? We can't justify a full rewrite of the entire code base. Quick performance win, as I was saying earlier, right? Like it's an easy way to say, hey guys, I know what I'm talking about. Let me do this. You do this. Great, it works. I'm not going to say it's 100% coverage, right? You're definitely test. Don't just assume it's 100% coverage. Drop in and then deploy to production. You're going to need to make sure you run in a dev environment, integration, staging, wherever you're running this, right? Non-prod, at least, when you first make these changes. And then, once everything is working, all your tests are passing, move into prod. Benefit here, like we saw earlier, right? Huge speed up with almost no code changes. So really great for fragile code bases. Polars. Performance critical, building production pipelines, new projects. I think that's a big thing right here too. Like new things should not be built in pandas. Huge speed up over baseline pandas, lower memory, more expressive API, scales much better as we saw. It was not linear. Other things, yes, it requires learning new API, smaller ecosystem, but it's growing more and more every day. And it's not, you can't do everything you can do with pandas and polars, but for the most part. And DuckDB, as we saw, I mean, polars was amazing, DuckDB was better. I would say here DuckDB is really great when you're a SQL forward team, right? You could do a Python wrapper, no problem, but most of your transformations can happen in SQL. That works out really well when you need to run complex aggregation and you want polars level performance with SQL syntax. Familiar SQL syntax, excellent performance, great for analysts, all those things are true. And this is my analogy that I made. I said DuckDB is to polars like Snowflake is to Databricks, right? Polars, Spark, distributed computing, Python, it all kind of goes together, right? DuckDB, Snowflake, SQL, it all goes together. So, production recommendations, polars and DuckDB are both great choices. It really, again, to me, depends on who your team is and depends on what your team wants to work on, right? And how they feel comfortable working. Not what they want to work on, but how they feel comfortable working in terms of, do we like using Python? Do we like using SQL? Benefit of DuckDB too is you could add in DBT. You could have DuckDB layered in with DBT. It's a really, I think, powerful for the modern data stack combination of using both DuckDB and DBT. Migrate existing code. So just some quick things, right? Quick wins. You could switch over to PyArrow. Again, test in non-prod environment. Then focus your low-hanging fruit, the things that are going to be your 80-20. Rewrite those in either polars or DuckDB, right? And analytics queries can be written in DuckDB. So we're getting a lot of cost savings. The efficiency can save a ton on cloud compute. You can run polars and Snowflake by writing Python code, no problem, and it does improve performance. Polars also has GPU support, so if you were to write polars code on a GPU, which Snowflake has GPUs, the polars gets even faster than what we saw today. I did not test on a GPU. I think I could test on a GPU in Google, the Google notebooks that they give you access to. Those do have GPUs available. TCP-H is a learning tool. Yep. So industry recognized test cases. Test anywhere from the size to megabytes to terabytes. So this is something I'd recommend, right? If you're just looking to pit technologies against each other, this is a really great way to do it. The TCP-H, I actually had my own data that I generated, but then I realized that this would be a much better way to put these technologies against each other and use the right tool for your workload. Justify technology decisions to stakeholders. I mean, kind of, but stakeholders don't really care. This is more of like the podcasting. They don't really care what we're using to get to our goals unless they're very technical stakeholders that want to know what's going on. A lot of times you don't have to do this, right? But it is good to say, like, give them numbers and say, you know, we're working on migrations that are going to bring 2x to 30x improvements. 2x great, 30x amazing. Set performance baselines for your team, identify optimization opportunities. Yep, all these I think are possible. Maybe not through the benchmarks, maybe with the benchmarks, depends on how you're interpreting and using them. And then finally here we have additional resources, the Polars user guide, the DuckDB documentation, TCP-H spec. And this took up about 3.7 gigabytes on my computer. I'll delete it after, but actually generated the datasets too with a DuckDB extension, which you'll be able to see in the data generation folder as well when you're looking through this. So I didn't even have to go out and download them. Like DuckDB was able to go out, download them, and put them on my computer. So as much as I used to be like Polars fanboy, I still am. But DuckDB, man, it's a really great tool, and I would say anyone who's not using DuckDB needs to be using DuckDB. And of course polars too. You need to be aware of both of them and how to work across different contexts. I think that will make you really powerful as an analyst, scientist, engineer, whatever it is, right? Choose the right tool for the job. It can either be polars or DuckDB. The other two being Pandas and Pandas with PyArrow add-on, I would say those are all like brownfield migration type work, fragile code bases, things that we can't introduce a lot of change to, because that does happen a lot in enterprise environments without needing to get 17 levels of approval for the changes that we make. So those types of changes in those types of environments make sense to me. The polars and DuckDB is where we should be building anything net new. Right? I think that's the important thing. So here you have polars GitHub, DuckDB GitHub, TCP-H benchmarks. Polars and DuckDB both have also really active developer communities. They're always improving every day, getting better. So definitely look at the GitHub, look at the issues, definitely contribute if you can to either any of these projects. They're doing really, really cool work, and I'm excited to see where polars and DuckDB end up. And competition breeds innovation, and competition always encourages people to get better and work on things. So really, I think both these tools are great. Both these tools should absolutely keep doing what they're doing, because if it were only to be one of them, then it wouldn't be as fun, because there wouldn't be as much competition. Anyway, I hope you enjoyed this notebook. Definitely feel free to message me if you have any questions, comments, concerns. It was a lot of fun to walk through this and to build this. This notebook, I think unlike some of my other notebooks, took a lot more time behind the scenes to make happen and to get right, especially some of these charts and proper memory mapping and usage and understanding just how all of these things played together, because I think it's really important to, when we're doing benchmarks like this, and we're going to try to say that like DuckDB is better than polars, right? That's an aggressive statement, so I want to make sure I've put the work in to feel confident in what I'm looking at and what I'm saying. Of course, provided the caveat to you that there is another polar option, right, that I could have tested, and don't have that necessarily in this notebook. So I'd love to see if you build that in, what that turns out to be. So hope everyone enjoyed this. Again, let me know if you have any questions. I'm always happy to chat, and reach out to us if you need anything else. But it's been a lot of fun doing these notebooks. I hope you've enjoyed it as much as I have and as much as we have. And until next time, this has been Sam with Saturdata. Bye.